we're inviting you to come study with us.
Hope you guys enjoy this fun and enjoyable video.
Have fun!
Hi guys!
As of now, we are on the 7th week of our first quarter. And for this vlog, we will be reviewing some of our lessons as part of our preparation for our upcoming exams.
And we're actually at the physics lab now to go study here.
Let's go guys! Let's start now.
Good day everyone, welcome to our physics class. Today we will be discussing our lesson in General Physics 2, which is electric circuit. Electric circuit is a combination of any number of sources and loads connected in any manner which allows charge to flow. So there are two types of circuits, the series and the parallel. So in a series is constructed by combining various elements in a series. In parallel, as we will notice, we have here lines that are parallel to each other, having their point of connection, which we call nodes. So we have here various variables present in a circuit, which C stands for capacitance, having the unit of farad or F, and V stands for volts, having the units of volts, V, and Q stands for charge, having the unit of C or coulomb. Now, we will proceed with our series circuit.
Take it easy for that discussion, and now we're gonna talk about the series capacitor combination formulas. The first formula is charge. Charge equals capacitance times volt. Total volts equals V sub 1 plus V sub 2 plus V sub 3. And total charge equals Q sub 1 equals Q sub 2 equals Q sub 3. And now, total capacitance is 1 over the sum of 1 over C sub 1 plus 1 over C sub 2 plus 1 over C sub 3. And we can input it in our calculator like C sub 1 raised to negative 1 plus C sub 2 raised to negative 1 plus C sub 3 equals to negative 1. Now, to test our knowledge, we're gonna do a simple problem. Given the total volts of 12 volts, given the capacitance of 5 microfarads, 6 and 7 microfarads respectively, we're gonna find the total charge, which is Q1, Q2, and Q3. And we're gonna find the individual voltage. And for our solution, we're gonna find first the total capacitance. So this is the formula for total capacitance. Total capacitance equals 1 over the sum of 1 over C sub 1 plus 1 over C sub 2 plus 1 over C sub 3. Let's substitute the givens. 1 over 5 microfarads plus 1 over 6 microfarads plus 1 over 7 microfarads equals the total capacitance of 1.9626 microfarads. And after that, we're gonna find the total charge. The formula for total charge is total charge equals to total capacitance times total voltage equals, let's substitute the given 1.9626 microfarads, which is our total capacitance times our total volt, which is 12 volts, equals 23.5512 microcoulomb. Okay? So now we're gonna find the individual voltage. Now, the formula for individual voltage is total charge over total capacitance. Now we're gonna find that first voltage. We have here the total charge. It is 12 over 5 microfarads. Divide it, and we have 4.7102 volts. Next, the second volts is 23.5512 over 6 microfarads. Divided, and we have 3.9252 volts. Next, the last volts is 23.5512 over 5 microfarads equals to 3.3645 volts. And that's how you solve the series capacitor combination. Now, we're gonna look for how to solve the parallel connected capacitors. Now, it's up to you, Ishi.
Okay, thank you so much, Will. We will now proceed with our parallel connected capacitors. And with that, we will be using the following formulas. For the general formula of charge, we will need to multiply volts and capacitance. To find the total capacitance, we will have to add C sub 1, C sub 2, and C sub 3. To find the total charge, we will have to add Q sub 1, Q sub 2, and Q sub 3. And finally, for our total volts, it is equivalent to V sub 1, V sub 2, and V sub 3. With that, we will now proceed with our sample problem. To apply what we have learned, we will now be solving a sample problem. Given here is 24 volts and the capacitances of 2, 3, and 4 microfarads. Now, we will be solving for the total capacitance, individual charges, and the total charge. To solve the total capacitance, we will only need to add the given capacitances. So that's 2 plus 3 plus 4 microfarads, equivalent to 9 microfarads. Second, we will be looking for the individual charges. First, for the first charge, we will be multiplying C sub 1 and the total volts, that's 2 microfarads times 24 volts equals to 48 microcoulombs. For the second charge, we will be multiplying C sub 2 and the total volts, that's 3 microfarads times 24 volts, that's 72 microcoulombs. And lastly, for the third charge, we will be multiplying C sub 3 times the total volts, which is 24, so that's 4 microfarads times 24 volts equals to 96 microcoulombs. To get our total charge, we will only need to add all the given charges. So that's 48 plus 72 plus 96, and we have here our total charge of 216 microcoulombs. And that's for our parallel connected capacitors. And we hope that you learned something today for our general physics class.
Good day, everyone. Today, our subject is Media and Information Literacy. And the topic is the evolution of traditional to new media. And the first age will be discussed by Aiki. Go, Aiki.
Thank you, Will. The first age in our timeline here is pre-industrial age. Pre-industrial age is an era of media that existed prior to 1700s. Considering that it is the first age in the evolution of media, advancement of technologies is not evident at all. So with that, it is given that in pre-industrial age is where people utilize primitive developments such as creation of fire, making paper out of plants, forging weapons and tools with stone, bronze, copper, and iron. How do they get informed of the happenings, you might ask? Well, with extremely limited resources available, it is inevitably difficult for them to access news and information. And so, the primary method of communication in pre-industrial age was done through person-to-person interaction or storytelling. However, with the continuous progression of the society or the world at large, media manifested its own existence, which brings us to the second age of media that will be tackled by Ray.
And the next age that we're going to talk about is industrial age. This is where the industry is at its peak because there's so many inventions that focuses on the industry. In the industrial age, discovered the following: using power steams, developing machine tools, and establishing iron production. Its communication consists of newspaper, motion pictures, typewriter, and many more. And now the next age is gonna be talked by Ishi.
Thank you so much, Ray. Now, let's proceed to our third age, which is the electronic age. The electronic age started in the 1930s up to the 1980s. During this time, people paved way for various developments such as the invention of transistors, in which we harness power from these transistors that led to the invention of transistor radio, electronic circuit, and the early computer. Also, let us remember that the electronic age paved way for the development or improvement of efficacy in the long-distance communication. Now, let's proceed to our last and fourth age in the evolution of media.
Thank you, Ishi. And now, we're gonna talk about the last age, which is the information age. The information age is the age of now. It is the age that we all live in today. The main focus of information age is the internet. Some of the devices that used in this age are laptops, tablets, cell phones, and some wearable devices. The communication in this age is very accessible because some apps are meant for communication these days. Like, for example, Messenger, Telegram, Twitter, and some others. Okay guys, that's it for media and information literacy. Hope you guys learned something from us today. See you tomorrow!
Good day everyone. Today we are talking about thermodynamics and enthalpy. In this, Q is equals to mc delta T. That's the formula if you want to find the Q. But what if we want to find other variables? Here, if we want to find the m, we just have to bring down the c and delta t. To do that, we have to rewrite it first. First, we have to bring down the c and delta t. Because there's an equal sign to it, we also have to bring down c and delta t here. After that, we have to cancel this 2 because it's the same. Two things divided by the same is equals to 1. So the only thing remains is m. So m is equals to q over c delta t. It's also the same when finding c. If you want to find the c, we have to bring down m and delta t. If you want to find the delta t, we have to bring down m and c. To double check our work, we have to know what this is. Q is calories, m is grams, c is calories over grams degrees Celsius, and delta T is degrees Celsius. So Q is equals to cal. C is cal over G degrees Celsius. And delta T is degrees Celsius. In here, we have to cancel cal and cal, C and C. And the only thing that remains is G. So, the right thing that we are finding is M, and the value is grams. It's also the same in enthalpy. This is much easier because it's only kJ mole and kJ mole. If you want to find the energy release, we just have to find mole and kJ mole, and we have to cancel it. So the only thing that remains is kJ. If you want to find the mole, we have to divide energy release over delta H, and we have to cancel kJ, so the only thing that remains in mole, and it's just the same over and again. To further understand the lesson, here is Ivy to discuss the sample problem.
Thank you, Ray, for that wonderful discussion. Now it's time for us to apply what we have learned with Ray's lecture. And we have a sample problem here about thermodynamics that says 5 grams of copper is heated from 20 degrees Celsius to 80 degrees Celsius. How much energy was used to heat copper, given that C is equals to 0.092 calories per gram degree Celsius? The first thing we have to do here is to identify the given so we wouldn't get confused on the process. So the given here is M is equals to 5 grams, the initial temperature is 20 degrees Celsius, the final temperature is 80 degrees Celsius, and the C is 0.092 calories per gram degree Celsius. The next thing we have to do is to identify what we are looking for. So we could use the right formula and thus arrive at a accurate answer. Now here, what we are finding is the amount of energy used to heat copper. And for our solution here, the first thing we have to do is to write the formula that will be used throughout the solution. And the formula is Q is equals to MC delta T. And to arrive at the final answer, we have to substitute the given to the formula, which is 5 grams times 0.092 calories per gram degree Celsius, 80 degrees Celsius minus 20 degrees Celsius. The reason why we have to subtract 80 degrees Celsius and 20 degrees Celsius is because in our formula, what we need is the change in temperature. And to be order to do that, we have to subtract the two temperatures given. And with that, we have to cancel the grams from the grams here at the C. And we also have to cancel degrees Celsius and degrees Celsius from the temperature. With that, we will arrive at a answer of 27.6 calories.
Good day everyone, welcome to our PE class. Today, we will be reviewing our lesson in PE, which is First Aid and Camping. Camping is one of the most exciting recreational activities that we know. And in every camping, there's a possibility that someone might be injured. So for today, we will be reviewing the proper procedure on how to move an injured body without lifting the person.
In such an incident wherein an injured person cannot be lifted, we may use the blanket drag in moving his body. Upon witnessing the person, we must be first vigilant of our surroundings. In checking the person's condition, it is important to first check his consciousness, breathing, and pulse. The next thing to do is call the authority and report the person's condition. They may give us mindful instructions on what to do while waiting for the arrival of the emergency team. In performing the blanket drag, we will gather half of the blanket. Then, we will position the person and roll him on the side. Place the blanket under the person and then roll him onto the blanket. Gather the blanket around him and move him carefully by pulling it from his shoulders. And that's how we execute the blanket drag in moving an injured person without lifting his body. We hope you learned something today in our PE class. Keep safe, everyone!
And that's all for our review. We hope that you enjoyed studying with us.
Being a STEM student could be difficult at times, but for the sake of being a one step closer to your goals, and along with the right company, I think it will be completely worthwhile.
Our lessons might be difficult sometimes, but let's remember that we can push through it all. As Marie Curie said, we must have perseverance and above all, confidence in ourselves.
That's true, Ishi. Always remember that if you do believe in yourself, there's nothing you can do. That's all for today.
See you around!
Bye!
everyone.
That's it for me.
Hi guys! Welcome to our vlog! Oh, ba't di sila nagsalita?
I saw it. Okay,